Today we're going to talk about operations with radical expressions, and we're going to start with a little bit of a review. If you were given an expression like this and asked to simplify it, you would combine like terms. That means x's add with other x's to give you 15x, and y's add with other y's to give you positive 3y. The x's and the y's cannot add together because they're not like terms. Well, the same rule holds true with radicals. You can only add and subtract like radicals. So 14 radical x's plus 1 radical x would give you a total of 15 radical x. The like part does not change. 15 radical y's minus 12 radical y's would give you a positive 3 radical y. And that's just how easy it is. So I want you to pause the video here and try these three. All right, these are pretty easy to do. You'll remember that there's an understood 1 here. That's why it ends up being negative 6 radical m's. And here, the radical xy's add with other radical xy's, and the radical y has nothing to combine with. Sometimes it's not this clear cut. So I want to give you an example. In this case, this does not look like these are like radicals. But what I need to do is I need to simplify both of the radicals first and then check to see if they're like radicals. So radical 45 is actually 9 times 5. And radical 20 is actually 4 times 5. I take the square root of 9. It comes out as a 3. So this becomes 3 radical 5 simplified. Take the square root of 4, that comes out as a 2. So this is 2 radical 5. So in reality, my problem is 3 radical 5s minus 2 radical 5s, which leaves me with 1 radical 5. So simplify the radicals first, and then combine your like radicals. So pause the video and do that. All right, take a look at each one of them very quickly. What I did was simply separate them so that there was a perfect squared factor. Now I took the square root out, and you've got 3 radical 5s minus 2 radical 5s gives you radical 5. That was our example. Over here, 75 we broke down into 25 times 3. 50 was 25 times 2. Square root of 25 is 5. That gives me 45 radical 3. Square root of 25 is 5. Gives me 10 radical 2. There's nothing I can do there. Okay? Love this one. All right, this was 25 times 3y, 9 times 3y, and 16 times 3y. Took the square root of 25, came out as a 5. Square root of 9 was 3, came out here. 2 times 3 is 6. Square root of 16 is 4. So I've got 5 radical 3's minus 6 radical 3's plus 4 radical 3's, which gives me a total of 3 radical 3's. See how that works? Okay. On this one, I simplified it, and again, they were not like radicals, so I cannot combine them together. And the last one here, square root of 4 is 2, square root of 9 is 3, and I ended up with 5 radical 3's. Now let's go back and review multiplication and division. So here, if I multiply two terms together, I multiply the coefficients together to get a 12. I multiply the x's together to get x cubed. I multiply the y's together to get y to the 4th. I think you should remember that by now. Okay? Here, if we're dividing, we divide the coefficients. So 15 divided by 3 is 5. We divide the x's. X to the 4th divided by x squared. Remember, subtract the exponents is x squared. And y to the 7th divided by y to the 1st is y to the 6th. I did not have to have like radicals in order to multiply or divide. So that means I'm not going to have like radicals in order to multiply or divide the radicals. Okay? It's really simple. What's on the inside multiplies times other things on the inside. What's on the outside multiplies by other things on the outside. And then simplify to make sure that your radical is in as simplest form as possible. So here's some examples. Radical 8 times radical 6. Those are both underneath the radical sign. That gives me radical 48. Now I need to simplify this. So I can break that down into 16 times 3. The square root of 16 is 4. 4 radical 3. Okay? Now, you might want to pause the video and attempt these and then come back and look. Okay, take a look at these. When you square something, you multiply it times itself. So 2 times 2 is 4. 5 times 5 is 25. Square root of 25 is 5. That comes out front, and we've got 5 times 4 is 20. Okay, underneath the radical sign, 3 times 12 is 36. Y times y is y squared. Square root of 36 is 6. Square root of y squared is y. Here you've got the distributive property. So I go radical 3 times 7. Now, the radical 3 is underneath the radical sign. The 7 is not. They cannot be multiplied together. So it's just written 7 radical 3. Here, the radical 3 and radical 8, they're both underneath there. So that's radical 24. Simplify it, reduce it, and these are not like radicals, so I cannot put them together. Okay? Do you remember FOIL? We're going to do the same thing, but with radicals. So let's do that. Okay, ready? 3 times 2 is 6. 3 times radical 8 is 3 radical 8s. Negative radical 8 times 2 is negative 2 radical 8s. And a negative radical 8 times a negative radical 8 is a negative radical 64. Now let's simplify this. Ready? This is actually 8. So 6 minus 8 is negative 2. 3 radical 8s minus 2 radical 8s leaves me with 1 radical 8. Okay? Here we have a binomial that is squared that has a radical in it. My suggestion would be to rewrite it. 4 plus radical 3 times 4 plus radical 3 and do FOIL. Pause the video and do that. Okay, so we did FOIL, first, outer, inner, last. This is what we got. The square root of 9 is 3. 3 plus 16 is 19. 4 radical 3s plus 4 radical 3s gives me 8 radical 3s. Okay, so now we're going to divide and we're going to do something called rationalizing the denominator. You are not allowed to leave a square root in the denominator. You cannot happen. So in this case, radical 11 divided by radical 3, I can't do anything to simplify that. There's no perfect squares that will divide evenly into those or be factors, but I'm not allowed to leave that. So what do I need to multiply the bottom by to get rid of that? Well, I need to multiply by a radical 3, because if I do that, that's going to give me a radical 9 on the bottom, which is actually 3. If you divide the bottom, if you multiply the bottom of a fraction by radical 3, then you need to multiply the top by the same thing. Now, the reason for that is because this has a value of 1. And you can multiply by anything that has a value of 1 all day long, and it doesn't change the value. It may change the way it looks, but it doesn't change the value. So this is going to give me radical 33. There's no perfect square factors of that, so it ends up staying a radical 33. And again, this process is called rationalizing the denominator, taking the denominator and turning it into a rational number. Okay, so let's try a couple. Ready? Pause the video first and try them, and then come back and look at it. Take a look at this first one. Simplify the denominator first, and it became out 2 radical 5. Well, I know I'm not allowed to leave that radical 5. So I multiply the top and the bottom by radical 5. That gives me 65, radical 65m on the top, and 2 radical 25. The square root of 25 is 5. Comes out, makes that a 10. 65 doesn't have any perfect square factors. We are finished. Okay? All right, let's do the next one. Okay, again, I simplified the radical 80 on the top first as 16 times 5. 4 came out, 8 radical 5. I'm not allowed to have the radical on the bottom. It's okay on the top, but not on the bottom. So I multiplied the top and the bottom by radical 7, and I ended up with 8 radical 35 over, and you'll see I didn't write this out as radical 49. I'm hoping you're getting the idea by now that a radical 7 times a radical 7 is just a plain old 7. Okay? All right, this last example I put on here because I want you to see that sometimes it's to our benefit to go ahead and simplify as if this was one big radical sign first. And in this case, you see what happens with these 3's. They cancel out. So really what I have here is radical 1 over radical a, and there is a, oops, that's an a. There is a square root of 1. It's 1 over radical a, and that makes this a lot easier. I'm going to multiply the bottom by a radical a, the top by a radical a, and that's going to give me 1 radical a over a. Now please do not cancel these out because the a on the bottom is outside of the radical sign, the a on the top is inside the radical sign. Okay? And one last one. Pause the video and try to do this first. Remember, sometimes it's better to pretend there's one big radical sign, and there might be things that you can cancel out or simplify and make it easier, and then we'll go from there, okay? All right, the first thing I would have done is canceled out the case because I don't even need them. All right, so we've got on the top 25 times 3, and on the bottom we've just got 10 radical 2. The square root of 25 is 5. So we've got 5 radical 3 on the top and 10 radical 2 on the bottom. Now, I noticed right away that I can simplify this. You can simplify it now, you can simplify it at the end. It doesn't make any difference. I am going to multiply both of these by a radical 2. So that's going to give me 5 radical 6 on the bottom. And 10 times 2 is 20. Make sure this is in as simple form as possible. So 5 will go into 24 times. My final answer is radical 6 divided by 4. And that is it.